So programming is an odd thing. It's been about 70 years since the first programmable computer, the Zeus Z1. And still, we grapple with this idea of computational behavior, of when a human tells a machine what to do, actually what it does, the unseen ramifications of our decisions. These poor little robots have very simplistic rules about avoiding each other, yet they're stuck in some horrific complex loop which the programmer had no realization of, i.e. me. But we haven't been sitting on our asses for the last 70 years. The fact that we're here programming means we have a bunch of solutions to this. We turn to computer science, where the general approach to the messiness of humans is to move to a more mathematical formal model, where we can make proofs, where we can rely more on specification. And this is fantastic. This is the basis of most of our programming languages, but it kind of removes the human and doesn't really answer the fact that you can still do stupid things. It's just that you can't wipe out your memory or your hard drive unless you're using C. Engineering. So the school of engineering, I guess, is more about process and practices. So this, I guess, is what we a lot talk about, thinking about unit tests, integration tests, regression tests, sandboxing, encapsulation. We have all these techniques to try and predict what the machine is going to do, and what the human told it to do is actually what it does. Now, those two are fairly common, I think, to everyone, but the kind of thing that I want to focus on is the performer. And the performer has a very different perspective to those other two schools, in that there's not so much a focus on long-term building. It's more focused on expression. And thinking specifically about code, it's more about code being the interface, rather than building something that is an interface. And the possibility of taming like the tiger of raw computational complexity on stage is terrifying, and is also what makes it live. There has to be a risk in live, right? I mean, that's why we go to see a live gig. There's more passion, there's more danger of them screwing up, the guitar strings could break, many things could go wrong, and to me, that's a very important part of programming. This is where the live coder comes in. Live coding is simply the idea of writing algorithms and adding to them in real time. It's something that probably most of you have done. If you think of IRB, you're live coding. It's just that we don't tend to do that in front of an audience of all these people, understandably so. But it's a fantastic way to explore and experiment, right, and have very fast feedback. Something kind of special happens when you have your code and it manifests itself in the physical space. So this is an example taken from Gödel Escher Bach, and we have these instructions, this language here. We have no context of what it generates. We know that in programming it's super useful to have fast feedback. You break a bit of code, you immediately see a test failure. That's very valuable. When we perform code and it does something like play music or have an output, that enables you, the audience, to have your own semantic meaning of the code. And I'm going to kind of drill on about this, but if I suddenly show you the output and you can see the output next to the program, maybe it comes, maybe it doesn't. This is simply where the dots are representative numbers, P is plus, and Q is equals. And there's something kind of special that now you look at those symbols, they're no longer random characters. Suddenly you see meaning in that code. And that to me is something I'm really interested in and really passionate about. We have huge amounts of power at our fingertips as programmers. There are so many things we can control, and I feel like we're only now beginning to touch the iceberg of what we can actually do. Not just building engineering systems, but how we express ourselves. Poetry is one thing that's live coded. This is an example taken from Newcastle in London by a guy called Alex McLean. Code is already literature. Code is already poetry. There was a Stanford 2015 Code Poetry Jam, or Bash, something like that. Or basically, people wrote code, and then the code was poetry. It executed the code, and it also read aloud poetry. So it's, again, that factor of having the code and being able to see the output in the real world. Kcci is a researcher currently in New York who's experimenting with the idea that you don't need a computer to live code. So what she's doing here is live coding a human. She's projecting her code screen onto the ground there, and the dancer is following the instructions. And again, this has this special thing of not just seeing the performance, but seeing the choreography and being able to connect it and see the artist's interpretation of that and what they do with it. She's done some fascinating research. I really recommend checking her out. This is a band called Slub, and what they've been doing is generating music and graphics. But what's particularly interesting is that they've experimented with different ways of visualizing code. Performing live changes everything, and most IDEs are not very capable of dealing with that. So in this example, what he's done is, with a Lisp language, has simply used the closures as bricks. And the flashing lines are actually the connectivity of the music as to what things are active. And you kind of see he can drag bricks, move bricks around, moving scopes and closures. This also, segueing onto something I think we can learn from computer programming, is it's so immersed in live feedback, it kind of makes normal programming feel a little bit dead. And there's something interesting in that. Yes. Karen Myers at Strange Loop 2014 live programmed robots. She had a drone flying, and I think she had 2 Sphero little balls. So another thing you can program. As well as live coding, lots of people are doing interesting things around weaving, around teaching kids programming, all through this live stuff. I think live coding is an art form now. It exists a little bit in the niche. It tends to be more musicians who are doing all this stuff. And to me, that's the kind of problem I want to tackle. And in doing that, we need to take those random symbols which have no meaning and try and give more people meaning. Generally trying to build audiences for code so it can become a more acceptable mainstream art form. There we go. And we do this by injecting code into children's brains. This is my daughter. I experiment with her with music. Here, she's actually playing Sonic Pi. Different parts of the keyboard are mapped to different sounds, so she just mashes it, but it's fun. Sonic Pi is a Ruby-based language which is used to generate music. It runs on one of these wonderful little Raspberry Pis, $30, which means this is massive in the school system. Lots of people are using these to teach. And there's, in fact, a whole bunch of teaching resources around these. Teaching music through live coding, not really about the coding, it's more about learning musical theory without the overhead of having to play the instrument. Also, learning programming is something I'm really passionate about. It's an extremely creative way to express yourself, and I think that's a fantastic way to teach children programming. This is already going on in the UK. A whole bunch of schools have started using these. There's lots of school orchestras popping up where the kids are live coding music. And that, to me, is extremely exciting. So if you're looking out for the next Daft Punk, it will be live coding, I hope. So before I go into my demos, something really interesting also happens with Sonic Pi. Sonic Pi takes a whole bunch of disparate groups of people who don't necessarily communicate very effectively and kind of brings them this common ground of music, of coding. I myself am a programmer. I've gone to music concerts and festivals and performed programming. And musicians have come to programming conferences and performed there. And to me, this is kind of beautiful and something we're lacking in terms of diversity of mindsets, of not just being about engineering, where the money is, not being just about computer science, where the power is, but being about creativity and expression, which is where the innovation is. So now, for the next 10 minutes or so, I have to live code. Since the talk is about live code, it kind of makes sense. And this will all horribly go wrong, and that's good because it's live, and that's the way that live works. Scary is good. So first thing I'm going to start with is Sonic Pi. And if we're approaching Sonic Pi, we should approach it as a small kid. So the first thing we want to do is the fastest possible route to feedback. So play 60. Ooh, caps lock's on. And we take caps locks off. Wow. That's kind of cool. But everything is actually inherently concurrent. So if I play 62, another note, they sound together. So already we're dealing with concurrency without really knowing about it, but we understand music. But that sounds a little crap. Let's try something a little more musical. Okay, very simple sample. And I don't really know much about programming, but I do know that I want my music to continue playing, right? That's fairly simple. I'll turn it down because this will explode. Ugh! And it died, right? Because we're inherently functioning in a concurrent world. Oh, it's still going. Let's stop. We didn't tell it to stop. It just played infinitely through time, samples. So what we need is a sleep. And this is not actually a thread sleep. This is adjusting for garbage collection and prior execution time. So in fact, this is like sleep. You can think of it as a beat, and it's actually internally calculating a delta, which guarantees timing. So now when we hit play, in about 3 or 4 lines of code, we have something very simple, music. But we also want to then do more, right? So we want to play another sample. So let's try something a bit different. And you'll notice it doesn't play, right? Because we're stuck in an infinite loop. It's just stuck in a loop. So we need to introduce concurrency, which I did not cover until my first year of university, and 6-year-old kids are learning this stuff, live loops. So this is ultimately just putting these two things into threads, and we do teach threads to small kids. And they get it, because it's music, right? I mean, you want two things to play at the same time. That's a ridiculously simple concept. So now when I hit play, but you'll notice they're completely out of sync, right? So we need to learn how to do concurrent coordination. Holy crap. Hi. So we need these two threads to be able to synchronize with each other. Oh, no, actually, let's do that other way around. No, that's right, yeah. What did I stop? Did I mess up? Let's remove the sleep as well. Ooh. Wow, this is live. I killed it. Okay, let's just move on. So from here, we can actually continue running our algorithm, and we can start live editing and messing around with variables outside. Because in fact, inside each of these live loops, it's just a function. And every time you evaluate the code like that, you're actually executing a function. Let me just take these cues out. Ooh. There we go, that's better. If in doubt, just make it. Yeah. Okay. And sync. Wow, I really did kill it. That's fantastic. But the point is they can keep running and editing this. And then you can kind of start to play with making more complex algorithms, looping through iterators, and also then thinking about case statements and checking when beats are equivalent to certain numbers. And you can kind of see from very simple coding concepts, we're building up a more and more complicated algorithm, getting our music a little bit more complicated, a little more in depth. I actually wanted to show you briefly, let's do examples first. So that's great, but we want to be as accessible to kids as possible and for musicians, so they can grab just a bunch of examples. So there's lots of built-in documentation in Sonic Pi. I'm just going to grab Blue Monday, it's not even Monday, but let's play that. So they can just grab something and start playing. Wait for it. And the cool thing is they have this running, and then they can then start modifying it live, right? And mess around with the octaves, and just experiment. This is fantastic for learning music, for just hearing, and the feedback loop. It's a lot of fun. I actually spent most of one day when I was here just sitting by the river, working on the piece, and what I said, we're very close to the material here. This is just Ruby, so there's no reason why Ruby programmers, musicians, and kids can't start to get more involved in more programming. Some kids have done some fascinating drum sampling algorithms of trying to create encoded like ones and zeros to express hits. All I'm doing in this example is changing the level of abstraction, so rather than doing anything in code, I'm actually doing it in poetry. And I'm just converting those into notes of music. So let's just try something to see if this works. Great. could really just play with this all day. I probably spent about 4 hours just messing around with this stuff. Okay, segue. That's Sonic Pi. It's available on the Mac, Windows, and the Raspberry Pi. It's on all Raspbian machines. Now what I want to show you is not Ruby, but in fact it's Clojure. More because I want to show you, for my small part of working on Sonic Pi, where I want Sonic Pi to go. And a lot of that is about visuals, which I think makes these tools even more accessible, especially to people with partial hearing or any hearing problem. Being able to see the sound is a really important thing. And also for confidence, for people who don't really know what they're doing like me. So I'm just going to go flat out here and see how far I get, and we'll see what happens. Please don't hate me for using Clojure. Ooh. Now let's do that one again. F31314. It always takes a little while to get booted up in Progo. think coding is a hugely passionate and exciting thing. Thank you very much, guys. It's a pleasure.
DJ Joey Wilk. Available for weddings, bar mitzvahs, and schoolie parties.